Morning.
Good morning. Good morning. All right. Good morning, everyone. Good morning. Hope all is well and everything's all right. All right. So, looking at where we left off. Anybody try anything, get stuck on anything? Try any problems?
Good morning.
Good morning.
I had a question about the math lab,
hmm
and I'm confused on which one to buy. I had a class says MDA 60, DO2P. I don't see one with the DO2P.
Oh, well, you don't look for that necessarily, but just the one that's assigned to MD 60. Because that section is for, just this class, but they got MDE 60s for every, for multiple sections throughout, the 4 different campuses.
Okay, so it doesn't matter which one I buy, I still have access to the math lab.
Right. You're probably not going to see one that says DO12P because that's just our section. But when you go to Barnes and Nobles, the MDE 60, the whatever is assigned to MDE 60, that's the one you will purchase.
Okay, thank you.
Right. Let's see. I believe we're looking at functions today. Yep. Just looking at one more thing in math lab. All right, so it should be 10.6. Oh, shoot. All right. 10.6. I'm looking at functions. I'm going to go to another section before we go here just to make sure we're okay with how we set up our functions. So that red note is for me. But 10.6 functions is what we're about to do. All right, so we're going to start off with the definition of a relation. So a relation is any set of ordered pairs. So here's an example of that. 1, 2, 3, 4, 5, 6. All right. Set of all your first components of the ordered pairs is your domain. So in this case, 1, 3, and 5. And then your range will be the set of all of the second components in your ordered pairs.
And Mr. Tucker.
Uh-huh.
Good morning.
Good morning.
Can you go up a little bit to the order pairs you had out there? Right there.
Yep. No problem.
Thank you.
Uh-huh. Give you guys a chance to write it down. All right, scrolling up some. May not be able to get to all of the blue yet, so wait a second. All right, are we okay with domain? All right, so differences between the two in all comparisons. So we already mentioned that it's the first component versus the second component when we're looking at domain and range. That means your domain will be your X and your range will be your Y. Domain is your input, range is your output. Domain is your independent variable, range is your dependent variable. So going back to input output, domain is normally, or your X values are the normally the values you plug in, the range will be the values you get out. Independent, your range depends on your domain. And then the last one, your domain will be a horizontal axis when your range will be a vertical. Mm-hmm.
One more time, the tests are open book, right? Notebook, right?
No, not far the tests are concerned. No, those, you can use your calculator. I have to check with Mr. Davis on if they allow a note sheet, or I believe they allow formula sheets. So let me check with him on that. He normally gives you the stipulations on how they do the test. I can check with that and get back with you. I don't believe it's just open notes though. You know, but you can use a calculator. All right, let's scroll up. Say right down with the blue. All right, so the definition of a function. Function is a relation, in other words, a set of ordered pairs, a relation in which the elements from the domain correspond to exactly one element in the range. All right, so the first exercise on the function, determine whether each relation is a function. Let's scroll up. Everybody done with the definition? All right, so I'm gonna erase this out. So determine whether each relation is a function. So they give us 1, 6, 2, 6, 3, 8, 4, 9. So what I do to show that it is a function, give you a visual that it is a function or not a function, I create a mapping of my domain and range. Notice my domain is 1, 2, 3, 4. Range is 6, 8, 9, 6 repeats. So you don't have to write it, but you don't have to write it twice. Okay. So now, if you go back to the definition of a function, function is a relation in which each element, in which the elements from the domain corresponds to exactly one element in the range. So if it fits that definition, then it is a function. So when you look at number 1, and we can look at each one of these individually and see if it goes to one element in the range. So 1 goes to 6. Does it go to just 6? The answer is yes. 2 goes to 6. Now remember, it's all about your element in your domains go to exactly one element in the range. So does 2 go to exactly one element? The answer is yes. Even though it's going to the same element that 1 is going to, that has nothing to do with the fact that 2 does not go to, it doesn't go to 6 and 8. It just goes to 6. So it goes to one element. So the answer is yes. 3 goes to 8. So that goes to just one element, and 4 goes to just one element is yes. If you can answer yes to all of these, then yes, it is a function. All right. Somebody trying to come in. Uh-huh.
I mean, what you mean? I just need to see another example because I'm confused.
Okay. Do you want to try asking the question on this one to see if we can get clarity? We got one more example, but I just want to make sure I answer the questions if I can. You know what I mean?
So you telling me, so just because 1 goes to the 6, that's why it is a function? I'm just lost on that.
No, remember, you're going back here to this definition.
Okay.
It says that your elements in your domain, you remember domain are your first, 1, 2, 3, 4.
Mhm.
Each one of them goes to one element in the range. So 1, you leaning on this relationship, 1 goes to 6. So it only goes to one value. 2 goes to 6. 3 goes to 8, and 4 goes to 9. So this is a function because each one of these goes to only one value over in the range. So you'll see in the next one how that can differ.
Okay.
Yeah, and maybe that'll make help you decipher between the two. All right. So can we go to the next one? So about okay. All right, this is nothing. Okay, so the next one is 6, 1, 6, 2, 8, 3, and 9, 4. So they pretty much just reversed domain and range. So once again, you want to ask yourself, does each value in your domain go to exactly one value in the range? So when you look at 6, 6 goes to 1, but also 6 goes to 2. And that's a problem. So since 6 goes to more than one value, it is not a function. And that's our conclusion right here. Questions on the differences between the two, when you would have a function, when you wouldn't. All right, so are we good on that? Then I got a few statements that will hopefully help bring more clarity to when you do have a function and when you do not have a function. So if you notice, we had a repeated value. We had 6 repeating in our range. If that was okay, it still was a function. But when we had a repeated value in the domain, they ended up not being a function. So that's a statement there that we could use to help us determine if we have a function or not. There can be a repeated value in the range, but no value can repeat in the domain. And then
That's the
here,
statement I was looking for, Mr. Tucker. I was looking for that statement right there.
oh, okay. Well, man, give me a chance, man. You know, I'm gonna make sure you're straight. Well, yep, there you go. And then the other one, maybe the other one may help as well. You know, whatever works. So I try to reword it, give you another statement. The range can go to more than one value, but the domain can only go to one value. So that's just another way of stating that right there. So.
Mr. Tucker, is it the same scenario when those are negatives for the domain or the range?
Yes. So whether it's negative or positive doesn't change the relationship. Yeah.
Okay, great. Thank you.
Mhm. All right, anybody still copying this? All right, going off the screen to the next one. Let's see if this can do it for us. Okay. All right, so we're going here, starting here, function notation. So writing an equation in function notation, y is equal to f of x. So all that means is that you're going to replace y with f of x, and then that will be considered function notation. And notice here, labeling how you would say that when you see f parentheses x, that's f of x. Here, if you see g parentheses t, that's g of t. So that's our function notation. So if I have the equation y equal to 2x plus 1, if I want to write that in function notation, I replace f of x with y. And so this right here is considered being in function notation. So from this point forward, they will expect you to remember this relationship. F of x and y are interchangeable. You can be within a problem of explanation, you know, in a book or whatever, and they can switch f of x and switch y back and forth and assume that you know that they're the same thing. So they don't change the value of anything. It's just that f of x and y can be interchanged. Once again, f of x, when you use f of x, that's considered the function notation. The equation is now in function notation. Okay, so what that does for us, in mathematics, if you ever decide to, you know, just watch and observe what they do, they try to write it as the least amount of words as possible to give you instructions, and just use symbolisms and letters, and then that'll be it. So they could say the sentence, oh, let me see. Okay. They can say the sentence, find f of 3. Or they could just write f of 3. They don't even have to write find. But if you want to know what f of 3 is, what that means is that I'm going to take 3 and plug in where I see x in that function. So there's instructions just in f parentheses 3. Of course, you have to know what f of x is first. Once that's defined or established, then if you see something like this, that just means you will plug in 3 into the function wherever you see x. So 2 times 3 plus 1, that's 6 plus 1, which is 7. Also, f of 3 equal to 7 is the same thing as your ordered pair of 3, 7. In other words, 3 is x, 7 is y. I plugged in 3, got out 7. Remember we talked about input versus output, domain versus range, x versus y. So when you plug in 3, we already said that was our x. We got out y, which is 7. Who's this? Trying to figure out if I should answer this door or not. I guess I should. Give me 1 second. Know who this is. Hold on 1 second. Sorry about that. One of the joys of teaching from home, I guess. All right, so let's scroll up. So for the next example, or the first example under this function notation, here they give us the g of x squared minus 5x plus 7. And they tell us to find g of 0 and then g of negative 2. All right. So if you want to find g of 0, that just means you're going to take 0 plugged in for x. So it's going to be 0 squared minus 5 times 0 plus 7. 0 squared, of course, is 0. 5 times 0 is 0 plus 7. So that will just be 7 as a result. And once again, here, I'm just emphasizing the fact that your ordered pair will be 0, 7. This would, if they tell you to find g of 0, this is your answer right here. But once again, I'm just making sure that we see the connection, just in case it's asked of you in the future or even in this problem. But your answer would be 7.
Moving a little too fast there for Mr. Tucker.
Oh man, we about to go. No, just messing. All right, sir, not a problem. I'll slow up. But are you good with A and what we've done so far? Make sure you're good with what we've done so far. All we did was they gave us this function. They established it. Now remember, don't forget, when it comes to function notation and all this stuff, they have to establish what the function is. So they give us g of x. You don't have to go find it. They give us g of x, and then the first one says find g of 0. And that just means plug in 0 where you see x in your function. We did that and calculated or simplified, whichever way you want to look at it, and got out 7. All right. Then the same thing for negative 2. Plug negative 2 into that same function, because we're talking about that function that is g of x. And then calculate negative 2 squared is negative 2 times negative 2, which is positive 4. Negative 5 times negative 2 is positive 10. And that's a plus 7. So we add 4 plus 10 plus 7, that'll be 21. And once again, that negative 2, 21 would be the ordered pair that's produced from that relationship. Know if you have any questions.
No, sir.
All right, and scroll up some. Let's see how we doing with the purple. Are you still copying? Okay. Next exercise, find the domain. So I wrote some notes here before we actually find it, to let you know what the mindset should be before you go into trying to do so. So your domains represents, talking about the red over here. Domain is going to represent all the values that can be used for the equation for x. In other words, all the values that you can plug in for x. So in order to find all the values that I can plug in, it will be easier for us to evaluate the values that you cannot plug in, or in other words, the values that you cannot use. And so that will be dictated by what type of equation you have, or what type of expression you have. Here we have a fraction, 1 over x plus 5. So that's why we're looking at this as a fraction specifically. You'll see how when it changed, we'll look at it a different way, looking at a different problem. But here we're looking at a fraction. So a fraction cannot have 0 in its denominator. So you want to know when is 0, when is the denominator 0? That's what you want to look at. So don't forget, 0 in the denominator is undefined. No, I don't have enough room here. So 0 in your denominator is undefined. And that's always going to be the case no matter what math you're in. And it causes a problem no matter what math you're in. So if you ever have 0 in your denominator, that is a problem. So what we want to do is figure out when is our denominator equal to 0. All right, gonna scroll up. Of course, I don't know where you guys are in the notes, so I'll let me scroll up if you still copying. Okay, so we have f of x equal to 1 over x plus 5 to find the domain of a rational expression. Rational expression is just another way of saying fraction. So to find the domain of a fraction, you set the denominator equal to 0 and solve. So based on your denominator, because remember, we don't want the denominator to be equal to 0. So we set x plus 5 equal to 0 and solve. So that's what I did right here. X plus 5 equal to 0. Subtract 5 from both sides. That's x equal to -5. So this is the value that cannot be used. So whenever you have a fraction, you set your denominator equal to 0, solve. And what you saw there will be the value that cannot be used. So every other number, though, can be used. And so that's how we're going to set up our domain. So this will be the domain. So notice it goes from negative infinity to -5. Then I use my union sign, -5 to positive infinity. So whenever you use parentheses, remember we talked about interval notation. Remember whenever you use parentheses on a number, that means you cannot use that number, but you can get as close to that number as possible. So I can use -5.1, -5.0001. I can get as close to -5 as possible. I just cannot use -5. So that's what the parentheses mean. And that's why we use parentheses here instead of bracket. But I can use everything else except for -5. Everything that comes before and everything that comes after. All right, questions on that? Scroll up, everybody okay? All right, so the next one, g of x is equal to 3x minus 1. So here, we're looking at 3x minus 1. Once again, you have to ask yourself, are there values of x that I cannot use? In other words, is there something, can I plug in for x? Is there something that I can plug in for x to make the equation undefined? So remember before it was -5, plugging in -5 into the denominator gave me 1/0, which would make my function undefined. So that's what happened in our last example. So here you have 3x minus 1. You ask yourself, is there anything I can plug in for x to make it undefined? Just regular numbers. So in this case, the answer is no. There's nothing that you can plug in there to make it undefined. It's not a situation that's created here that will make it undefined. It's just a regular equation. You can plug in anything, it'll work okay. All right, don't want to scroll up too fast. But there's nothing for a regular equation that you can plug in to make it undefined. Scroll up. So since nothing can make this undefined, we would set our domain as -infinity to infinity. So all values can be used. That's what that means. Any questions? Any questions? Okay, got one more down here. Nope. Yeah, well, different type of problem, but not like that. Let me see if they have square roots. Okay. All right, so those are the only type that I saw. Just scroll up. All right, so next set of directions. Let me see how many more of these. That's it. Thought so. Okay. Next set of directions, find the domain and range. So wrote a few notes over here as far as the range and the domain. Don't forget your domain, all your x values, and you write them from left to right. It's always your least to greatest. So your domain, x values, horizontal, left to right. Your domain, your y values, when you write those intervals, you're going from down to up. It's always your lowest value to your highest value, or your lowest value to your greatest value. So since your range is your up and down, your vertical axis, you write your lowest value first, down, and then you go up. So looking at our endpoints, we have -3, -1, 4, 5. So now when you're talking about your domain, you're going from left to right. So that's -3, 4. We're just taking the x value in each order pair. So we're going from -3 to 4. Use bracket to include. So those are solid. Let me see, do we have open circle? Oh, no, open circles. Probably should have put an open circle in there. Let me see if they. Oh, but I wrote it right here. Okay. So notice right here in the purple box, because we have closed circles, then we use brackets. If one of them was an open circle, you would just use parentheses, you know. So just reminding you of that. And then for your range, notice is -1 to -1 to 5. And so that's why we have -1 to 5 here. All right, questions before we do one more? All right, so here we have the parabola. So we have our lowest point, our vertex, which is 3, -2. So if we want to look at our domain, remember your domain goes from left to right. And as this goes up, because you see that our parabola is going up, as it goes up, we continue to get wider and wider and wider. And basically that's going to continue to get wider into infinity. So that's why our domain is -infinity to infinity. And then when we look at our range, our lowest value is 3, or our lowest point is 3, -2. Now, don't forget your range though are your y values. So we wouldn't use the 3, we would use the -2, and then it goes up. So that means that's going from -2 to infinity. All right. Questions on what we did here up to this point?
No, sir.
Thanks, sir. Thanks, sir. Okay, so that's it for 10.6, and that closes out chapter 10. So we stop right there. We don't have to, jump into anything new. Next class, I'll open the floor for questions first, and then see if you and we'll just see where we go from there. Now the question is though, for you guys, I know a couple people have contacted Mr. Davis about testing. Make sure you follow up so you can go ahead and get that test in there. And for those who haven't, make sure you go ahead and do so, because you do want to go ahead and get a test under your belt. Because the further we move along, they are expecting you to get those tests in. You will contact Mr. Davis at jldavis@tcc.edu. Don't forget to CC me. And yeah, that'll be it. All right, questions on anything before we close today?
I have a question. So, so we have a quiz and a test for the material that we've done so far.
Let me see. There is a quiz up there. It's more like a study plan. Hold on, this is a quiz right here. Yeah. The main thing though, that's pretty much preparing you for the test. The main thing that you need to focus on and the main grades that I'm looking at are your homeworks and your tests. That review quiz will help you, and the study plan will help you to prep for the test. But because there are certain grades that you have to get. So for your homework, you have to get at least that 75 or better. No, I think I said 75. Yeah, it's supposed to be 80, but I think I initially told y'all 75 or better. So we'll just leave it like that. And just 70, and the test 75 or better as well. And then your final exam. Nope, I think you guys just have all tests. So scratch that, just all tests. So you want to get 75 or better on all of your homework assignments and all of your tests. Like I said, if I'm not mistaken, it's supposed to be 80, but I told you initially 75, so I'll just leave it like that. But we want to score at least 75 or better on all of your tests and all of your homework. And so that's going to be the marker for you guys.
So for that practice quiz, we don't have to contact Mr. Davis for it. We just do it on our own.
Yeah, and it should be set for an infinite amount of times on it as well. Yeah, so you should just be able to freely do that. But the test is the only thing you have to contact Mr. Davis on. I can spell his name, right? And don't forget, we're not asking you guys to come in. You contact them. They got a Zoom link and Zoom information to send you guys. And then from there, you do have to confirm what time slot you're going to come in and actually take the test. So when he contacts you or responds to your email, make sure you respond back with confirmation on when you want to take that test. All right. Anything else? Anybody else?
So am I understanding correctly then that the test is over Zoom? It's not in person. Is there an option for being in person?
You can ask him that. You can
Okay.
ask him that, but I know initially what he's going to think is that you're talking about a Zoom, scheduling. So yeah, you could just let him know if that's what you would like to do. Let him know that, and then they'll go from there.
Okay, thank you.
Mm-hmm.
I have a question.
Yep.
So how do we find the previous Zoom recordings?
When you go into, let me see if I still have my stuff up. So when you go into Canvas, go to MD60, go to your class, of course, hit announcements, and it would be the emails entitled class lecture links. And then there you go right there. So that was the last one I sent. And then this was one I sent the week before, and I have your links like that. All right, so any email that is titled class lecture link will have links for your classes.
Okay, thank you.
Not a problem. I also send them in an email as well. But like I said, if you miss the email, they will always be in your Canvas announcements. Anything else? Anybody else before we close it out? Okay. So as always, try the stuff out. Take this weekend to generate some questions. Like I said, I'll open the floor for questions first and answer any questions you got. Even if we take up the whole class period answering questions, I'll open the floor for you guys to do that first. So we have really, at this moment, 2 tests that you're held responsible for. So let's make sure that we're prepared going into them. And like I said, I don't have to do anything new next class. If you guys have questions after the class period, then so be it. I'm fine with it. And we'll go from there. All right. So you guys have a good one. Be safe. And I will see you on next class. Have a great weekend.
Have a great
Thank
weekend.
you. Have a good one.
Thanks. You do the same.